Welcome to ICU Primary Prepcast. Hi, my name is Swapnil, and in today's primary snippet, I'm going to cover the sequence of events that occur after the vessel injury leading up to the blood clot formation. So, formation of blood clot following vessel injury is characterized by sequence of events and involves following steps. First is vascular spasm. Smooth muscles in tunica media layer of vessels contract dramatically in response to endothelins, which are released by vessel lining cells. Now, large vessels differ from small vessels as they got additional longitudinal layer, and the contraction of this layer is not as effective as in small vessels. And hence, the larger vessels do not vasoconstrict in response to bleeding as effectively as small vessels. Now, this phenomenon of vascular spasm lasts for approximately 30 minutes. The second step is formation of platelet plug. Now, there are some key structural elements of platelet which help them in performing this function. First is actin and myosin molecules and thrombothelin. Now, these proteins help platelets to contract. The second is mitochondria, which are present in platelet, which help to produce ATP, which is required for this contraction process. Platelet also produce growth factor, which causes growth of vascular endothelial cells, vascular smooth muscle cells, and fibroblast, which eventually plays a role in formation of clot. Platelets have unique ability to produce van Willebrand factor, which is responsible for adherence of platelets. Also, prostaglandin, which are secreted by platelets, plays an important role in local vascular and tissue reactions. Last but not the least, the cell membrane of platelet has a coat of glycoprotein, which helps in adhering to injured endothelium, but it prevents adherence to normal endothelium. And that's why we do not see platelet plug formation in normal vessels, but when they get injured, we see platelets adhering to each other. The phospholipid of platelet membrane contains platelet factor 3, which plays an important role at several points of coagulation cascade. Now, once platelets are activated or come in contact with injured endothelium, they secrete 5-HT, which leads to vasoconstriction. Further to this, there are several structural changes happen in platelet that include they begin to swell, they become irregular, and they form pseudopodia, which protrude from their surface. Contractile proteins like actin, myosin, and thrombothelin contract forcefully, and they facilitate the release of granules from platelet. This process makes platelets quite sticky, and then platelets attach to collagen fibers. Platelets also secrete large quantities of ADP and enzyme called thromboxane A2. These both ADP and thromboxane A2 cause activation of nearby platelets, and other platelets go through the similar process of becoming irregular, swollen, and then they start adhering to each other. And all these sticky platelets come together, clump together, and they form a platelet plug. This mechanism is important to close minute ruptures in small vessels. Now, moving on to actual clot formation. The clot formation is initiated by formation of prothrombin activator. Prothrombin activator can be formed in two basic ways. One is the extrinsic pathway, and the second is intrinsic pathway. Now, the extrinsic pathway involves the tissue trauma, which leads to release of tissue thromboplastin or factor 3. Activated factor 3 facilitates the activation of factor 7 to factor 7A, and that leads to formation of factor 7A to factor 3 complex. Intrinsic pathway, on the other hand, is triggered by damaged vessel wall, which leads to activation of factor 12 to factor 12A. Under the influence of prekallikrein, activated factor 12 facilitates the activation of factor 11, and this activated factor 11 under the influence of calcium or with the help of calcium triggers the activation of factor 9. Activated factor 9 in the presence of calcium, factor 8, and thrombin leads to formation of activated factor 8A and 9A complex. Now, both intrinsic and extrinsic pathway, once activated, they eventually merge into common pathway, which includes activation of factor 10 to form the activated factor 10 or 10A. Activated factor 10 in the presence of activated factor 5 with platelet, phospholipid, and factor 3 helps in conversion of prothrombin to thrombin, which is activated factor 2. Thrombin further facilitates the conversion of fibrinogen to fibrin, which is factor 1. And under the influence of activated factor 13, this fibrin helps to cross-link these fibrin fibers and leads to formation of clot. And this is how the clot is formed. So key mechanisms involved include vascular spasm, followed by platelet plug formation, and followed by activation of intrinsic and extrinsic pathway, leading to final clot formation. And the last mechanism usually involves the clot retraction, which is due to all the contractile proteins, which I mentioned before. So that's the end of today's podcast of Primary Snippet. We'll be back in week's time with another snippet. In meantime, if you want to access the show notes, don't forget to visit www.critcareedu.com.au, where all the show notes can be accessed in the PDF format. See you next week. Till then, goodbye and have a nice time.